So I started the interpreter again. I have to give it a bit more space. Let me just quickly check whether the size is
The
still okay. Yeah.
previous size was better. Why do you reduce the width?
For the simple reason that I want to show the turtle canvas on the other side.
Okay.
That's what I'm going to do now. So as I said, there's this program. There used to be this programming language called Logo, which we used to take as child's play, things which you can draw squares or circles with. But MIT has a whole course called Computer Programming with Logo. And the book for that course runs into 3 volumes. And that actually deals with all aspects, all possible aspects of computer programming. Not just child stuff, but very, very complicated advanced algorithms were illustrated using the Logo language by drawing pictures. So I don't really want to, that such a course, of course, ran over 2 semesters actually. So I'm not going to do all of that in the little time I have left. So what I'm going to do is I'm going to quickly show you how to sort of understand some of the basic concepts of Python using the Logo-like module that Python has. It's a module called Turtle. And what I'm going to do is I'm going to sort of disobey my own stricture a while ago. I said you should not prefer dumping every name onto your namespace, but right now, just to keep things simple, and I'm going to use only, because I'm going to use only one module now, I'm going to just dump everything. So I'm going to use from turtle import star. So everything that is in the turtle module gets dumped onto my namespace. Now, one problem is that I should actually confess about one problem. If any of you are trying to run the code along with my lecture, you can of course do that, but the problem will be if you're using your mobile phone to do that, then the rest of the things which involve drawing on the screen may not work. Most mobile implementations can't draw on the screen very well. So those of you who are trying to follow using mobile, well, I'm sorry for that. You can't really follow that well right now. And anyway, you can of course use your laptop implementations or desktop implementations to do this. Okay. So, and one more thing, a while ago somebody asked, is the argument in degrees or radians? And the answer was, of course, radians, because that's the only measure that people should really be using for angles. However, in Turtle, we will use angles a lot, and there the angle is in degrees. That's basically because it's sort of meant for people who have not yet learned about radians. Okay, so what does it do? It essentially draws a turtle on the screen, although it doesn't really look like a turtle. I'm using the reset function, which actually resets what is being done, but I'm doing it to just show you what happens at the very beginning and move the canvas where the drawing occurs to one side so that you can see what's happening. So in Turtle, what you have is a canvas, this white square here, this window, and you have a turtle sitting in the middle of this canvas. Notice that this cursor is what is called a turtle. It used to be called a turtle because it moved on the screen and moved rather slowly. But that was when it was when the older computers were in use. Nowadays, it actually moves a bit too fast. Okay, but anyway, so this black thing that you can see here, the cursor that you see on the screen, this is called the turtle. And what you can do is you can use various functions which are there in the turtle module, like forward, and you can make the cursor move around. So forward is a function which has to be called with round brackets as arguments, and inside you have to give the argument itself. So the argument here is simply how much will the turtle move. It will move 100 units or 100 pixels here. So if I hit the enter key now, the function forward 100 is carried out, and you can see what will happen. The turtle moves forward, right? And what it does, it leaves a trail the way it's moving forward. Okay. So by the way, idle actually also gives you help on what various functions do. So as you can see, the moment I started typing right, it told me what does it do. So I'm going to turn it to the right. So imagine that you're walking along this path and your head is towards in the direction which the turtle is pointing. So right would mean to your right. It will turn right to 90. And if you look carefully, you will notice that the cursor hasn't moved, but just turned around. So now if I do forward 100 again, and then right 90 again, so using Puzzle, I've completed the most elementary of drawings. I've just drawn a square on the screen. But what did I do for this? I moved forward 100 units, then turned right to 90 degrees and repeated that 4 times. Now, as most of you would, of course, appreciate, where I'm going with this is that if you want to do the same thing over and over again, what any decent programming language would allow you to use is what is called a loop. So how do you write loops in Python? That's where I'm going with this. So to see that, let's reset the canvas again. So that gets rid of the drawing. We started with the turtle again back at the center and everything erased. And now we are going to write our first loop in Python. And for this, I'm going to use the for loop. There are different kinds of loops which are possible. I'm right now using the for loop. And the for loop has this syntax. You have to write for the name, which is the keyword, followed by the name of a variable, the variable which will change as the loop goes along. And what I'm going to do is something like this. This may be a bit unfamiliar to most of you or many of you, but when I write something in quotes, it means that this is a string. So quote ABCD means it's a string with 4 characters, A, B, C, and D. Now, this is an example of what is called an iterable. Iterable is anything which comes in pieces. So the quote, when you write quote ABCD, A, B, C, and D are the 4 pieces. So a Python loop can be written down over any iterable whatsoever. Anything which comes in pieces can govern a Python loop. So here, what happens when a loop runs is that I will first take the value A, then take the value B, then take the value C. A meaning A within quotes, the character A, then the character B, then the character C, then the character D. Of course, all I'm really interested in right now is that it's not the values it takes, but the fact that it's going to run 4 times, because the iterable ABCD has 4 pieces. So what I've written down right now is what is called the header line. So this is the head. So what I'm going to write is what is called a compound statement, a statement which is made out of several pieces. And the general syntax in Python is every compound statement has to start with a header line. So I'm saying for I in quote ABCD, end with a colon. Every compound statement has a header line which ends with a colon. That's the general rule. So once I hit the enter, notice one thing, because I'm using idle, which gives me some amount of help already. Notice what has happened. The cursor has moved inwards. This is because the general rule in Python is when you're writing a compound statement, you have a header line and you have a body. Body meaning what happens inside, in this particular case, what happens inside this loop. So when I say for I in quote ABCD, I will take values A, B, C, and D, and every time I take a value, the loop will run. But what will run in the loop? The answer to that is in the body of the loop, and the body of the loop has to be indented inwards. So here what I'm going to do is just two things. By the way, people who are familiar with logo might remember that they used FD and RT instead of forward and right. And in Turtle also you can do the same thing. You can use FD and RT. But anyway, these two lines which have been indented inwards, these are the two lines which form the body of my loop. So these are the two statements which are going to be carried out every time I changes its value. So this was my first elementary loop. I took 4 values. The loop ran 4 times. Every time it turned forward by 100 units, then turned right by 90 units. And that completed the square for you. Of course, do I have to use ABCD? The answer is no. And in particular, suppose I wanted to draw, instead of a square, I wanted to draw, say, a 20-sided polygon. Writing a string of 20 characters is a bit too much. So there are other ways of doing that. So is there a question? Now, this of course is really elementary stuff, but we are going to get into more complicated stuff.
Totally important in itself.
What? Sorry, I couldn't get you. Onaboda was asking something. Hello? I couldn't hear you. Okay, let me emphasize at least one important thing about the structure here. Every compound statement that you will ever write in Python, every compound statement that you will write in Python will have similar syntax, which is what I meant by saying uniformity of syntax, which is what makes writing Python easy. Not all, if you are using some other programming languages, indentation is often used by programmers to make the programs look easier to understand or look cleaner. But in most languages, that's optional. So some people who write programs in C may decide to indent the loop, body of the loop. Some people may not. One person may indent, another person may not. The same programmer at different times may choose to either indent or not indent, or indent by different amounts. The great thing about Python is that this indentation rule, that the body has to be pushed inwards by exactly the same amount. I'm using one tab stop, but all you really need is exactly the same amount every time. This is not a matter of style. It's not something which one person can choose and another person may choose to ignore. This is a matter of syntax. In Python, everybody, from the most expert programmer to somebody who is beginning, must use the same basic rule. That is, you have to write a header line which has to end with a colon, and the entire body has to be pushed inwards. So just to illustrate some further points, let me point out that Turtle has a function called color, and it's very easy to see what it does. When you say color, and inside the bracket you give the argument red in quotes, what you're telling Python is to change the color of the turtle to red. So if I do this, notice that the color of the turtle has changed to red. And if I now run the for I in ABCD code, what I'm going to get is that, move this up a bit. So if I were to run this loop again, which is very easy for me to do, let's run it again. Now, of course, I'm getting a red square because the turtle is red now. But now let us say I want to draw a square which is red, blue, red, blue. So how would I go about doing that? So of course, it's a very, very simple task, but the reason why I'm going to talking about that is we can illustrate various different programming concepts using this very simple idea. So one way would be simply to do something like this. I choose to choose a variable name. I'm calling it C, assigning it the value red to begin with. So C is a variable which has a string red as its value right now. Okay. And then what I will do is I'll go back to the loop, but I will modify the loop a bit. What I will say is at the beginning, I will say change the color to whatever the value of C is. Of course, if I ran this particular loop now, what will happen is that I'm going to get a red square, no matter what color the turtle was before. Now, of course, it's already red, but even if it was some other color, once it enters the loop every time, the color becomes the value of C, which is red. And that, of course, doesn't change inside the loop. But what we can do is modify that. And for this, I'm going to use another compound statement, which is sort of obvious. If. So if comes with a condition. If that condition is true, then do something. If it's false, then do something else. So if C notice this is also a compound statement, and as a result, it has to be written down as a header line with a keyword, then the stuff which goes with the keyword, in this case the condition C equals to red, followed by a colon. And most of you would already be aware that equality and assignment are actually two different things. And here what you have is equality. The equal sign so far here, when I say C equal to red, that was not somebody has the mic on. Could you, we are getting some external noise. Could you please mute your mic? Unless you want to say something, that is. I hope it's not my own mic. Okay, so somebody has the mic on. Could you please mute that? Okay, let's go back to where we were. We were talking about this particular loop. So if C is red, so that's the compound statement. And as you must have noticed, this is something idle does for me. If you were using some other interpreter, you may have to do it by your own, on your own. This indentation is automatically done by the idle interpreter that I'm using here. So if C is red, then there's a compound statement within a compound statement. So its body has to move further in. So what I'm saying is, if C is red, sorry, this is a mistake. This is what I meant. If C is equal to red, this is the equality check, actual equality check for condition, and this is assignment. If C is red, change it to blue. Else, if and else are at the same level because they're part of the same compound statement. Right now we have only two choices. C can be red or blue. So we are saying, so let us take a look at what we really meant here. We assign the value of C at the on the outside. C is red. And now I'm changing the color to whatever C is. So first time the loop runs, the pen will become red. But then it will check whether C is red. C is the same as red. So C will become blue now. Then we'll go and draw the whole thing. Then we will get the color to change again to whatever the value C is now. Then it checks what C is it red or is it blue? Because it's blue now, it will change to red, and so on. So when I run this code, of course, the answer is trivial because I can just run this code and find out. But can anybody tell me, when I run this code, when I say tell me, could you just type it out on the chat? Should I get a red, blue, or a blue, red, blue, red? There's the first line, the first horizontal line which the cursor will draw, the turtle will draw. Should that be blue or should that be red? Okay, unfortunate, yeah. Some people are saying red, blue. Some people are saying only blue. When I say RB, okay, quite a lot of different options it seems. BR, that's blue, red, I assume. Blue, red, blue, of course. So some people are saying that the first line will be blue. Okay, there are lots of options. Let's stop this now. We can find out very easily, right? We can just run this code. But it's very easy to figure out anyway. Notice that C is red to begin with. The color function uses as argument the variable C, which has value red. So now the pen color is red. Now what this if block does is that because C is red, it changes it to blue. So now C is blue, but the pen color is still red. Why? Because pen color is only set by the color function, right? So although C has changed to blue, the color of the pen is red. So the first line will be red. When the cursor moves forward, it doesn't matter what the variable C is. The cursor color has been changed at the beginning, and so you get red line. Then when it comes around, C is now already blue, so color C becomes blue. The loop changes, the if statement changes it to red, and so on. So let's see whether that works out. So red, blue. Just to remind you, changing C does not change the color. It's the color function which changes the color. Now, going along on the same theme, suppose I wanted red, blue, green in a hexagon. Okay. So what we could of course have done is something like this. Okay, let's reset this first so that we go back to the colorless thing. Now C right now has a value which is red. By the way, this looks more like one of those one of those puzzles where you're supposed to read what the word says. The word is saying red, but it's written in blue. So it's sort of a psychological test as to which one registers first, the color or the words. And of course, this is red. See, the variable stores the string red. Now, what we can of course do is something like this. I will just copy this code, which is easy enough to do in Python, in idle. So color C is red. Then C becomes blue. And because I want this order, if it's first red, then blue, then green, we can do else if, which is shortened to elif. And if it's neither of these two conditions work, so if C is already red, C changes to blue. If C is blue, else if C is blue, that's shortened to elif, then C becomes green, else C becomes red. So if C is green, then it becomes red. Of course, I want a hexagon, so I want to turn around by 60 degrees. Oops. Now you can figure out what went wrong. What went wrong is that my loop, unfortunately, was still running only 4 times, right? Because I had for I in ABCD. So let's start by resetting the thing again, but just to illustrate what really should happen. Oops, not here. So C was blue at the end of the last pass, so that's why you started with blue. But because it was blue, it became green, then it became red, then it became blue, then it became green, then it became red. So this is a nice point at which I can ask, are there any questions about this? Okay, somebody says, I am putting enter after else colon and it's coming invalid syntax. You are right. The point is, Python expects every compound statement to have 2 things: a header line, which has to end with a colon, and a body, which has to end with, which has to be there. So if you are ending without putting in anything else, without putting in a body, it's going to give you an error. In mobile, can I use turtle? The answer is no. At least not that I know of, because most of the mobile implementations that I know of can't really draw very well on the screen. Okay, can you again explain what is the meaning of I in ABCD? This actually is very, very important. So let me just point out again. A for loop has this syntax. The keyword is for, then you have a variable, whatever variable, it doesn't have to be called I, you could call it anything. It has to be a genuine variable name. And for I in, so I'm using I, but you could use anything else. For I in, now comes something which is in pieces. So can I draw crystal structural unit cells using Python? You're going a bit too far ahead, I guess, but you can. Not turtle, really. Turtle is more for demonstration. It's not really meant for that. But using matplotlib, for example, you can do that. Or my own suggestion would be, if you really wanted to do something that advanced, you would use something like, say, use LaTeX drawing, but LaTeX drawing can become very complicated. You can use Python to write your LaTeX code. That's one of the great uses for Python, because it handles strings so well. You can draw various things. Okay, let me just continue with for I in ABCD. This is an important point. For variable in iterable, that is the structure of the Python loop, for loop. Iterable is anything which comes in pieces. Right now I'm using the piece, I'm using ABCD, which is a string which has 4 pieces. Because the string has 4 pieces, I will take them piece by piece. So I will first become A, run the loop once, then the code becomes B, run the loop again, then becomes C, run it again, then become D, run it again. You want to run it 6 times? As somebody already suggested, when I goofed up and ran a hexagon with only 4 sides, just use for I in ABCDEF. How to draw a circle? Of course, you might think use an infinitely many sides. That really is not right. Python, well, of course, you can't write an infinite loop. That's one problem. The other thing is Turtle actually has a circle function. And if you want to learn how to use it, use help. Say help and use circle as an argument. It will tell you exactly how to use the circle function. Of course, you can also draw a polygon with a very large number of sides. It's going to look like a circle anyway. Okay, so let me come back to this issue about this iterable thing. As I said, you could use anything here including anything. No, you can't use anything here. For example, you can't use something like this. I want to draw a 6-sided picture. I tried for I in 6 and then said, okay, I'm using the logo style abbreviations. Now I'm getting an error message. And in Python, the error messages are very, very explicit. It tells you exactly what you are looking, what has happened. What is telling me here is this. When I said for I in 6 colon, the object here, 6, as a type, is called int for integers. Of course, this is going to be described in great detail in tomorrow's class and the day after, what different kinds of objects are and what their types are and so on. But this is pretty easy to understand. This is an integer object. An integer is one single thing. It's not an iterable. It doesn't come in pieces. Okay, there you have only one thing here. So it's not possible for I to pick out pieces from 6. It is, as it's saying, it is not an iterable, and that's why there's an error. Okay. So what it's telling you is that you have made a type error. What you wanted here was some kind of an iterable object. What you have is not an iterable object. Okay. But what other kinds of iterable objects are there? There are things called lists, strings. Strings you have already seen. There are lists, there are tuples. There are other things as well, but things like iterators and so on. So let's first start with a list. I'm assigning a list value to a variable, and the list here is a bunch of numbers right now, which I've separated by commas and put in a square bracket. So what I have now is a list. Okay. So L equals 1, 3, 4, 2, 6, 7. I've deliberately tried to jumble them together a bit. The values right now is not very important for me at this stage. What is important is that you have 6 such objects. And what I can do, I can run a loop like this. L here is a list. A list is anything you write within square brackets and separate out elements by commas. So when I say for I in L and say things like for FD 100, 40, 60, before I run it, I should bring the window up. Of course, I'm not changing any colors here. So whatever color the turtle is right now, which you can see is red from the head here, you're going to get a red hexagon. Okay. So what we have shown you is how to write a list. Use the square bracket to delimit the list, put entries inside, and that's it. A list has pieces, and here I becomes first 1, then 3, then 4, then 2, then 6, then 7. And you have got a hexagon for it. Now it might seem a bit of a waste to have to write down a list explicitly every time I want to run a loop. Suppose I wanted to run a loop 100 times. Would I really want to write a list which has 100 elements first? Well, you don't have to. For that, Python provides you with a function called range. So I'm writing a loop which is going to run 100 times because this range 100 is an object which has 100 pieces in it. In fact, the pieces it has are exactly 0, 1, 2, 3, all the way up to 99. Why 0? Because in Python, like in most programming languages, not Fortran, but in most programming languages, counting starts from 0. And it ends at 99 because 0 to 99 is exactly 100 elements. I'm doing something a bit strange. I'm asking Python to print what happens when you multiply star the asterisk. This within quotes, of course, is the asterisk symbol. This star is a multiplication thing by I. So you might have guessed what has happened when you multiply a string by an integer. The string gets repeated that many times. Okay, 100 may be a bit of an overkill, so let's do it for a smaller number. So first time around, I will take the value 0. So star, the single asterisk is going to be multiplied by 0, which means nothing will be printed the first line. Then 1 star will be printed, then 2 stars will be printed, then 3, and so on. Notice that there's this big gap here is because there is an empty line here, 1 with no stars. Then 1 star, 2 stars, 3 stars, 4 stars. Stops at 4 stars because range 5, the last entry it has, is 4. Now, let me just point out that right at this point, 2 of the most important differences between Python 2 and Python 3 is sitting right here in this small piece of code that I've written. We've already seen one difference, that is slash between integers in Python 2 is quotienting, and slash between even between two integers or any two numbers is just division in Python 3. That's one important difference. The other important difference is if you are using Python 2, print, the syntax is different. You just write print, not as if it's a function, you just write it like a command. You just say print, then put a space, then you write what you want to print. That's the other major difference. And the next major difference is what this range function does between Python 2 and Python 3. So to understand that, let's save L range 5 in the variable L. Now, let's see what this variable L has right now, what kind of an object it is. For that, I'm going to use a type function, which will be described in great detail tomorrow. Type L, tell me what kind of thing it is. Now, if we were to do this in Python 2, the answer would be type list. In Python 3, it's an entirely different kind of object. So Python 2, and if you say print L, oh sorry, okay, I've confused my Python 2 and 3. So I should really use print L. It just says range 0, 5. It's just telling me what is there in L. If you did the same thing in Python 2, range 5 actually returns a list. The list 0, 1, 2, 3, 4. In Python 3, on the other hand, range does not return a list. It returns something else called an iterator. It's really a special kind of object which is in a class of its own. But just to show you what you would see in Python 2, let me just use a list function to change range into a list. The output of range is given to the list function, which changes it into a list. And now L is really the list 0, 1, 2, 3, 4. In Python 2, this is exactly what you would have got with range 5. In Python 3, you get 0, 1, 2, 3, 4, only if you change it into a list. But by default, it's not a list. Okay, the reason why it's not a list, let me just quickly tell you why that is. Typically, you use range very often to control loops which may be running millions of times. Suppose you want to run a loop 1 million times, which is really not that big a number for big number crunching operations. So in Python 2, what you would say is something like for I in range 1 million. That would, of course, create a list with 1 million entries, 0 to 1 short of 1 million, all those integers. And that will take up quite a lot of space in the memory. However, most often what you use list range for is to control a loop, which means all you really need is to get things one by one. So what an iterator does is that it remembers what it sent you last time. So range 5, for example, the first time it's accessed, it sends you 0. But it remembers that it sent you 0. The next time you access it, you get the next entry. So the point is, you don't have to occupy a lot of memory space with 1 million, let's say, integers blocking up memory. You can just remember what was your last value and increment that by 1 or whatever increment you're asking for and get the result. Now, because the range is very, very important, let me just illustrate some other versions of it, some other ways you can use it. Range can actually be used with either one argument, as we have seen, or two arguments. For example, you could say minus 3, 5, two integers. And when you do that, it's going to start from minus 3, then go on, keep on going up in steps of 1, and falls just short of the stop value. So the first argument is called the start value, where you start. The last argument is called the stop value, but Python lists the range does not really stop there. It stops just before that. It will not touch 5. So these are two ways you can use range. I'm actually changing this into a list simply so that I can show you all the values at the same time. If you were using Python 2 again, the list is exactly what you would have directly got. You also use something like this. 3 arguments. It simply means start at minus 3, go until you stop just before 5, but go in steps of 2. So what you will get is minus 3, minus 1, 2 more than minus 3, then 2 more, 1, 2 more, 3, and then 2 more would have given you 5. Python stops there. So this is what range can give you. It can give you, if you use one argument, it gives a list starting, or it returns integers starting from 0 to 1 short of the stopping value. That's because that's exactly that many number that you are specifying. With 2 arguments, you have a start, you have a stop. With 3, you have a start, stop, and an increment. Now, if you use a 4, what happens? Notice that Python is giving you an error here. It's telling you range expected at most 3 arguments, got 4. Notice that it doesn't tell you it expected 3 arguments. It's telling you at most 3. Okay, that's because you can call range with either 1, 2, or 3 arguments. In fact, if you, on the other hand, called it with none, it's telling you expected 1 argument, because 1 argument is the bare minimum it has to get, got 0. So my point here is that error messages which Python gives you are actually very, very important, and you should really pay attention to what they mean. And one important thing about having the interpreter handy is that you can whenever you're in doubt as to what a particular piece of code does, you can try it out in the interpreter. If you get an error message, try to understand what the error message is saying and go along with that. Okay, now going back to the child stuff that we were doing, drawing hexagons with colors. Let me show you how to do it with a bit more style. Remember, we drew a hexagon with red, green, blue sides, but we did it using if, elif, else. Let me do it in a slightly more sophisticated way, but that sophisticated way actually illustrates some very important top points. What I'm going to do now is first I will create a list whose entries will be the 3 strings having the 3 color values. So red, comma, green, comma. So I have a list with 3 colors listed: red, green, blue. Okay. So what I will do is I will now, using what I've learned, I'll run a loop 6 times just by using the range function. And I will say, change the color of the pen. But I will take one element from this CS list every time. And I'm sorry, I should have told you this before, but this will be explained in great detail tomorrow anyway, tomorrow, day after. If you want to take a piece out of an iterator, any iterator, in this case a list, you have to use square brackets to index. So what I'm going to do, I will take the ith element out of C's and use that as an argument for color. And then just simply say forward 100. Now, if I run this code, what do you expect? Will I get a hexagon with red, green, blue, red, green, blue? So you could type out your answer. Do you expect that to happen, or do you expect something else? So any opinion? Or somebody asked a long ago, can we have a short break? Unfortunately, we are near the end. So, okay. So, frankly, we will not take a break. We will stop soon. It would have helped if I had seen that a while ago. Okay, let's see what will happen. People are giving us different opinions. And what will happen is, of course, I become 0, 1, 2, 3, 4, 5, or would have become 0, 1, 2, 3, 4, 5, 6 if the loop had really ran. Of course, the loop will run. I will become 0. CS0 is the very first element, 0th element of CS. Counting of indices start with 0. So that's red. So color will become red. It will go forward 100 units, then turn right through 60 degrees. Then then the body of the loop is completed. It will start all over again. I will become 1. CS1 will become green. So color will be green. So you get red, green, blue the next time. But then I become 3. And the only indices possible in the 3 index lists are 0, 1, and 2. You cannot get 3. So if I run this, you will get 3 sides of this hexagon. But then you are going to get an index error, list index out of range, because after 0, 1, 2, you have reached 3. And 3, of course, is not possible. It's not possible to take element number 3 out of C's. So just remember, counting starts at 0. So this is element number 0. This is element number 1. This is element number 2. There is no element number 3. And that's what this error is telling you. List index is out of range. But I would still want to use this list. So the way to do that is actually this. Percent is an operator whose meaning is calculate the remainder. So I percent 3 means calculate the remainder when I is divided by 3. So for I equals 0, 1, 2, the remainder of course is 0, 1, 2. But then when you reach 3, and your index would have ran out of range, you're actually calculating the remainder when you divide 3 by 3. So it goes back to 0. Then I becomes 4, remainder is 1. I becomes 5, remainder is 2. So 0, 1, 2, 0, 1, 2 are the arguments or the indices which CS gets. And so The arguments which color gets are the 0th, 1th, and 2th elements of CS, which means red, green, blue. And this will work. So I've just illustrated a very simple way in which you can write down lists and use lists. I will just end today by trying to be a bit more, sophisticated and advanced than what this child's play of drawings may have shown you. So I will do one calculation for you quickly using lists. This will be explained in more detail later. This is one of the most important topics later. There's something called list comprehension. So I'll just show you what I'm doing here. I'm asking Python to add up every element in a list. And the way I create the list is I calculate 1 over I square. Because there's Python 3, I can do 1 by I square, but just for the sake of everybody, somebody may be using Python 2, I might remember that dividing 1 by a number more than 1, integer more than 1 will lead to a 0 in Python 2. In Python 3, of course, it will give you what the fraction is. And even in Python 2, if you say 1 point, then you have a floating point number up here. Then division is an ordinary division. Again, different types, etc., will be covered tomorrow in more detail. So what has happened here is this. Okay, this one, I think the full window is fine. What I've done is an example of something called list comprehension. This will be covered in great detail later. I'm just saying this to impress those of you who were sort of rather unimpressed by just simple pictures of hexagons and squares and so on. Range 1, 100, this, how big is this? This is a million, right? 1, 1 million returns actually one element less than 1 million, 1, 2, 3, and so on. And for each of them, you calculate 1 by I square and create a new list. So this square bracket essentially here is being used for something called list comprehension, something which will be discussed in more detail later. But what this does is returns a list with elements 1 by 1 square, 1 by 2 square, 1 by 3 square, 1 by 4 square, and so on. Then when I say sum, it's just going to add up all of them. Oops. What happened? I must have, sorry, I put this whole thing in the wrong place. So let me just copy paste this whole thing. Somehow I wrote this whole thing in the middle of the loop. I just wanted this one line. And that's it. The calculation of pi square by 6, for those of you who know the infinite sum 1 by n square, this of course is not pi square by 6, it's a close approximation. Pi square by 6 is a sum for the infinite series. But this is all it needs, just one line, and you've calculated sum. You have summed up the series 1 by I square from 1 to 1 million. So I will stop here today and take questions if you have any. And now, since I have stopped talking, if you really have a question, you can even unmute yourself and speak up, but preferably do it one at a time, because otherwise it will be difficult to answer. And if you can type.
Can I have a question?
Yeah. Go ahead.
My question is this, that in 3.7 shell, I could get the turtle graphic slate, but the execution is not happening and it is showing syntax error.
No, if it's showing syntax error, it means that you must have perhaps missed out some sort of
thing. I have just done what you have written there.
No, that might be
line by line.
No, that might be because you may have missed out some subtle thing like a colon or like the indentation.
Is there anything whenever I have to run it by F5?
No, what are you using? Which shell? Are you using
I'm
idle
using
or
the Python turtle graphics.
No. Python turtle graphics is just this canvas. Are you using
Yes.
idle or some other shell?
Idle.
Using idle, all you have to do is go to the end. So let me just show you what I did
Yes,
here.
please show me 1 second.
So I'm copied the. This is if you just hit an enter. If you click on some piece of code, hit enter, you can copy the. Now what you need to do for I in range 6 colon, this has to be there.
Mhm.
And I'm assuming you are doing this one. So the CS array is already there. CS list is already there. And all the brackets are in place. Of course, you have to use the correct brackets and so on. But when you say syntax error, it might be because your spacing is wrong, your indentation is wrong or something. Okay, FD, RT. For example, if I did this, I will get an indentation error. It will say invalid syntax. The reason for that is an interpreter, an idle in this mode is also an interpreter, takes only one command at a time. Notice that Python understands how this is actually one command. Despite what it looks like, this whole compound statement is not 4 commands, it's only one command. Every compound statement is one command made out of several pieces. Now, here on the other hand, Python understands that this is one command because you have the header line and this is the indented line. So this is the head, this part is the head, this whole line here, and these 2 lines make up the body. But the moment you change the indentation, the moment you go back to the original indentation, Python understands that you have finished off that statement, you're starting a new one. In the interpreter, you cannot put more than one statement at a time. Here you're trying to put 2. So that might sound a bit strange because it looks like I wrote several statements at one go in the interpreter, but that's not several statements. That's actually one compound statement. Here, with this indentation, it becomes one compound statement followed by one single statement. And the interpreter will not allow you to do that. So that may be one reason. It may be simply a syntax error coming out of indentation. There could be many other reasons, but so unless I get to see it exactly, I will not be able to say. So, but there could be many other reasons. So somebody asked, how do I start a loop from 1 instead of I equals 0? Just say range 1 comma something.
Sir?
If you use 1 colon 6, for example, it's not 1 colon 6, it's range 1 comma 6. But if you use 1 comma 6, you will get only 5 entries. 1, 2, 3, 4, 5. Yes. So any further questions?
Sir, I was having a bit trouble with the else part. Like every time I was putting else and the next thing coming as a...
Okay, so if you are following along, that's great. But the important thing is if and else are part of the same compound statement. So both headers have to be at the same level of indentation. Where's the command for running the program? That depends on what you're using. If you're using an interpreter, you just hit enter. If you're asking where would you find the interpreter, that's a different thing. You have to install it first, I guess. So I can't answer this question until I know what system you really have in mind. And tomorrow, of course, they will discuss. Okay. Range -3, 5, 2. As I said, in Python 2, it will directly return a list. In Python 3, it returns something which is more efficient, something called an iterator. Python 2 actually has the same thing. Python 2 has something called xrange. Xrange in Python 2 is actually what range is in Python 3. But anyway, the basic idea is range can take up to 3 integer arguments: the start value, the stop value, and the increment. The increment is 1 by default. If you don't give it, if you give only 2 values. So let me illustrate this once again. List range 10. I'm just converting it directly to a list so that the interpreter can show you directly. It returns by default a value which starts at 0, ends at 9. Starts at 0 because that's where counting starts always in Python, and ends at 9 because that's where you're going to get exactly 10 entries. But that's only when you give a single integer argument. So with range 10, you will get 10 entries only if you give a single integer as an argument. You can give 2 integers. Then you are giving a start value and a stop value. That's a stop value now, not the number of terms. So it becomes 2, 3, 4, 5, 6, 7, 8, 9, and stops just short of 10. Now with 3 arguments, range actually has start, a stop, and an increment. So let's say I'm using 2, 10, 3 here. So I'm saying start at 2, go up to but just short of 10, and go in steps of 3. So what you're going to get is 2, 5, 8. The next one would have been 11, and 11, of course, is beyond the stop. So you will not get that. It's just a 2, 5, 8. You can actually, okay, suppose I did something like this. I mixed up and gave 10, 1, 3. So I'm asking Python to go from starting from 10 to go to 1 in steps of 3. Of course, it can't. It returns a list, but an empty list, a list with no entries whatsoever. Okay? Because you cannot go from 10 to down to 1 in steps of 3. But what you can do is go from 10 down to 1 in steps of -3. So 10, 7, 4, once again, the next one would have been exactly 1. It stops short of reaching the stop. So now you get a 3-element list. Well, I'm saying 3-element list because that's the list I've converted it to. In Python 3, what you get is an iterator which first returns 10, then 7, then 4. Okay. Any further questions?
Sir, I have a question. Sir,
go
I
ahead.
have a question. Sir,
Yeah.
when you typed delete math and
Hmm.
then you
Del
typed
math.
yes, del math, and then when you typed math.sign1, it showed an error, but
Yeah.
with sign1, it showed the answer.
Right,
Why?
because that was because, well, that of course was a result of the sequence of steps I had taken. Just let me remind you what we had done there. Let me just quickly do that again. I had originally done import math.
Yeah, because with sign1,
Now-
initially it was not showing any answer. So
Yeah.
you wrote import math.
So if I try sign1 now, it's telling me name sign is not defined. And if I look at the directory, okay, I have a lot of stuff in the directory because the entire turtle module has been dumped there. So looking at the directory right now may not be a great idea. So let me just do one thing. Let me go out and start the interpreter again, because otherwise too many things might confuse you. But let me just do this quickly. Take a look at what the directory has now. Now only special names starting with double underscores, ending with double underscores, and only things which are already inside those, like inside built-ins, can be used right now. Dir is inside built-ins, range is 2, so we can use them without importing any other module. Import math. Fine. Now the directory has this special name. Sign will not work because the name sign is not known. Math.sign will work. Because what you're telling Python is, from the use the name math which you already know. Inside math, look for sign, and inside math there is sign. and give that result, return the result. But after I did this, I did something else. I did so this is the order in which I did the thing. I first imported math, which was just the name math. Then from the math module, imported the name sign. So now you have in your directory both math, the name math and the name sign, which means now sign is a name which Python knows. So if I type sign1, it's going to work. If I type math.sign1, okay, I've gone below the visibility range here. If I type math.sign here, it will also work because the math module's name is also known right now.
Yes.
But then I did del math.
Yeah.
I got rid of the name math. Now let us look at what the directory contains. It no longer has the name math. So math.sign is unknown to it. Okay, in order to get to math.sign, it will have to first go to math, and from math use sign. It does not know the name math any longer, so it's giving you an error. It's saying name math is not defined. However, the name sign is very much still inside, right? Notice that they're still in the directory. I didn't get rid of that.
Yes.
So now sign1 will work fine. But if you want to do something like a square root of 4, it will not work. Because it doesn't know the name math, neither does it know the name square root. If I had instead done, instead of doing from math import sign, if I had done something like from math then as long as we want to use these 4 functions and only these 4 functions, of course, the line in this list, sign was not really necessary because I've already imported it. Importing twice makes no difference. The directory will still have just these 4 additional names: os, exp, sign, and square root. So as long as your calculations just need these 4 functions, you can happily use them. And you don't, not only don't you need to call them as math.sign, then you cannot call them as math.sign. Because what Python knows are just these 4 numbers. It's like from the box math, I've just taken these 4 screwdrivers out, put them on my table. It doesn't have the box, so it cannot. You cannot say math.cos. You can only say cos. Did that help? Did that help?
Yes. Thank you.
Okay.
Ananda,
So we are,
I think time is over. It is around 6 now.
yeah, so we can
And,
sort of, yeah, right.
Yes,
And
we
it's been a
can
long
wind up
day for
all
many
these
people.
things. And even
Yeah, I
after
think
this
we can wind it
session,
up.
even after
Yeah, we
this
can wind
session,
this up. And moreover,
participants can ask their questions.
yeah, I think
Participants can ask their questions in the WhatsApp group also.
yeah,
And
right.
then,
That's a good point. You can ask the questions in the WhatsApp group. Maybe we'll answer them at the beginning of the next round or at some convenient time. If you think that there are some questions which you might forget, please ask in the WhatsApp group. Of course, you can ask them tomorrow. And most of these things, remember, I just gave you a lightning overview of part of what Python is. Many of these things will be treated in a lot more detail tomorrow and the day after. And by the time I come back with my talk on NumPy, most of these things will already be explained over and over again, I guess. So
yes,
it should be okay for everybody.
Yes.
Sir, that part is solved
So
now.
let's thanks to. Sorry.
The else problem that I was talking about in my machine, that part is solved now. Now it's working in there.
Okay. The else, the if and the else have to be on the same line. That's important.
Yeah, exactly. That was the problem. I was just now it's gone like.
Okay.
So let us
everybody,
stop right here, and
and tomorrow also we will start maybe
let's
5
thank
minutes early so that we
the
can
speaker.
admit everybody. And
Yes.
Thank you, speaker.
You can thank us at the end if you really feel like thanking us then. Okay. When we end, by the time we end the workshop, if you still feel like thanking us, you can thank us then, I guess.
Yes. Yeah.
Okay, you write down.
Okay.
Okay, good. So we end the
So
session,
we
right?
will
Okay, so
meet
we
again
leave
tomorrow.
now. We leave now.
Yeah, tomorrow at 3
Okay.
p.m.
3 p.m.
Okay, thank
sharp.
you.
Okay. Thank you.
In the guest list will be given access, but let me